So now let's move on to question 1.9. So a little bit different to the question 1.8 that we've done before, because in this case we have a slope for the wire at 90 degree from the vertical. So let me read the question. The figure shows a conductor moving with a velocity of 10 meters per second to the right in the magnetic field. The flux density is given as 0.5 Tesla out of the page, and the wire is 1 meter length. What are the magnitude and polarity of the resulting induced voltage? So in this case, we have a wire here, like that. So this wire is moving in the magnetic field B. Can you see that there is dot 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 over there, meaning that B is directed from paper out of the page. Okay, so B is out of the page, and the direction of wire is displaced about 90 degree from vertical. So just can mark it as here is 9. Sorry, that was not 90 degree. As the question shows, it's 30 degree. So 30 degree displaced from the vertical position, right? 30, right? So we move this wire to the right direction. Let me use different color. We move this wire with velocity of v to the right direction. So from the question, we want to find the magnitude of the induced voltage and the polarity. So to know the direction of induced voltage, what we do is, as usual, we can use the left hand rule. Okay, let me draw my hand here. So I have my hand like this. Using the left hand rule, it should be looks like this. Okay, that is my hand. So this is V. I've got long thumb. So this is V, velocity, and my index finger is supposed to be induced voltage, and this is B. Now in this case, the wire is 30 degree, 30 degree. So let me just write down all of the information given as in the question. Okay, so for B is the flux density is 0.5 Tesla. V is also given as 10 meter per second, and L is 1 meter. So we want to find induced voltage. What is the magnitude of the induced voltage and also direction? All right. So very similar to the previous question, we want to find the induced voltage. In this case, we can just use the formula of E in equals to V cross B L, right? But in this case, we know that V and B is perpendicular, right? So V and B is perpendicular. B is out of the page, V is to the right. So V and B is perpendicular. We just can write it as V B sine 90 degree. No problem about that. But the problem is, how about L? Suppose L to be straight. If I redraw this wire, suppose we want this wire to looks like this. Wire, let me draw it on the original figure. Suppose we want this wire to be looks like this, straight. Okay, so meaning that we want this wire to be this direction, right? So what we do is, the purple one, and this one is L, this is L. If we see this, we already know that using trigonometric identity, for this one is L cosine 30 degree, right? That is the cosine component. And then we can also, let's say this one is L sine 30 degree, is it? Alright? Yes. So using L cosine 30 degree, just write it here. So L cosine 30 degree. Cosine 30 degree is 8660. Where's my calculator? So we just substitute all of the values that we have. From here, V B sine 90 degree is 1, L cosine 30 degree, right? So we have B. Let me write it here. So we have V 10, B 0.5, L is 1, cosine 90 degree, cosine 30 degree is cosine 30 degree. Where is cosine? Function, trigonometry, cosine 30 degree. Is cosine 30 degree is 0.8660. Okay, so we further calculate this. We get 4.33 volt. Which direction? Which is from top to bottom. So we can write it as positive at the bottom. So we can just mark it here. Just like the one in the figure, induced voltage is to that direction. That is the direction of induced voltage. So that's all. That is the answer for this tutorial 1.9.